Check it.
Okay, welcome back. We're going to learn some new factoring methods today. Higher order polynomials, things that go beyond quadratics. We're pretty good with quadratics. We know how to use reverse FOIL and AC method. But what if we want to go beyond that? I want to start off here by talking about a difference of squares. And I'm going to show you how that's going to help us go to higher powers. A difference of squares, just to review what it is when you have something squared minus, that's what the difference part is, not a sum, a difference. Something squared minus something squared. And if you factor a difference of squares, you get these conjugates here. You get a, whatever the first thing is, plus the second thing, and times the first thing minus the second thing. So the important thing here is, can you figure out what's being squared? That's how and then from there you can use this equation here. I don't want to call it a formula because technically it's not a formula, but it is an equation, a relationship here. So take a look over here. 4x squared minus 25. Is this a difference of squares? Yes, it is. What's being squared? You look at the first thing. That's your a squared. So if this is a squared, what is a? What would you square to get this? And then you have a minus. And then what are you squaring to get the 25 over here? Okay, so that's what I mean here by write this as a difference of squares. I literally want you to put these parentheses down and the squares outside. And now I want you to fill in the parentheses. So what would you put in this set of parentheses here that would give you 4x squared? Well, what would you square to get 4? You'd square 2, right? And what would you square to get x squared? You'd square an x. And there you go. 2x times 2x is 4x squared. And what would you square to get 25? A 5. Now that you've written it this way, you know that your a is 2x and your b is 5. And you can write your difference of square. You can factor this now. A plus b, a minus b. So it's going to be 2x plus 5 and 2x minus 5. And that's how we did differences of squares. If you remember, a difference of squares can be factored. A sum of squares, a squared plus b squared, is not factorable. Okay, you cannot, there's no such thing as a sum of squares. So what I've been saying is a sum of squares is not a thing. Okay, a difference of squares, important, sum of squares not. Well, for cubes, you actually have both. You're gonna have a difference of cubes and a sum of cubes. Here are the formulas right here. So you have a difference of cubes, something cubed minus something cubed, and it factors out like this, and don't be afraid of the formula, it's pretty easy to remember. And you also have a sum of cubes with a slightly different formula. Almost exactly the same, but a couple of things are different here. Just the signs are different. Okay, so our first example. Is this a difference or sum of squares? No, because there's a 3 here. So it's not square anything. Is it a difference of cubes? Actually, no, because 3 is not the cube of anything. What's the cube root of 3? It's a decimal. And 24 is not the cube of anything either. So this is not a difference of squares. It's not a difference of cubes. It's not a sum of cubes. It looks like it's absolutely nothing. But then, hopefully, you remember that with all factoring methods, no matter how advanced we get, you always start by finding a GCF. So come over here. Is there a GCF we can factor out of here? And you realize, yeah, 3 goes into both of these. So my first step is to factor out a 3. And now this becomes x cubed minus 8. Okay, double check it. If we distribute this 3, do you get this? Yes, you do. Now this 3 is a factor. Some students think, oh, it's not important, and they make it go away. No. That's one of your factors. Don't get rid of it. Now, can you factor this? Is this a difference of squares? No. Is it a difference of cubes? Maybe. Is something being cubed to give me x cubed? Yeah. And is 8 the cube of something? Actually, it is. 2 times 2 times 2 is 8. And let's just take the x cubed over to the side here. So this is the difference of cubes. What's being cubed here? So let's write our parentheses. Something cubed minus something cubed. What's going to go in the parentheses here? X. What's going to go in the parentheses here? 2. You need to show this step. This is a required step on the homework and on the quizzes. So don't lose those points. Make sure you show me this part right here. Now, from here, you can tell what your A is and what your B is. Okay, your first thing here, this is your A, something cubed, A cubed, minus, so this is a difference, not a sum, and this is your B cubed. So here's the formula. The formula is this right here. Okay, and this is the formula for the difference. There's a slightly different formula for the sum, but we're not going to worry about that right now. So now that I know what my a is and what my b is, my a is x, my b is 2. That means that this x cubed minus 8 equals a, which is x, minus b, which is 2, times a squared. Well, my a is, once again, my a is this, my b is this. So a squared is x squared, plus a times b. Well, that would mean x times 2, or 2x. You always write the number before the letter. And then finally, plus b squared. Well, b is 2, so this is 4. And there you go. You factored this difference of cubes here. Now, this is actually not the full answer, so I'm not going to box it. I'm going to come back over here. Now we have 3, which is our first factor. Don't forget about that. Times this right here, x minus 2, times this over here, x squared plus 2x plus 4. And this is your fully factored third power expression. So we're using the formulas up here. But the important thing is, can you figure out what a is? Can you figure out what b is? That's the most important part. Once you have that, it's just plug and chug. All right, so what about solving equations? Because sometimes you have equations that need to be solved via fact. The whole point of factoring, 90% of the time, is to solve and find roots and stuff. So here we go. We have what looks like, what might be a difference of cubes equal to 0. So can we factor this and use a zero product rule? Well, the first thing you need to do is say, all right, well, if this is a difference of cubes, I should be able to write it as something cubed minus something cubed. What would you cube to get 8x cubed? Well, to get an 8, 2 times 2 times 2. So a 2. And to get an x cubed, it would just be x. So 2x times 2x times 2x is going to be 8x cubed. What about 125? Well, it turns out that 5 times 5 times 5 is 125. So we know what a is, we know what b is. So now let's bring down the formula. The formula is, and since we know what a and b are, we can just plug them in now. A minus b, which is 2x minus 5. And then the second part is going to be a squared. Well, what's a? A is 2x, so 2x times itself is 4x squared. That's a squared. Plus a times b. Well, 2x times 5, that's going to be 10x. Now you might be thinking, hey, what about this? Is this a negative 5? No, no, no. Just look at the a and the b. The signs come from the formula here, okay? Finally, plus b squared. Well, b is 5, so b squared would be 25. Now that that's fully factored, we can solve our equation here. Okay, we have 2x minus 5 times this thing equal to 0. Once we get here, we have two factors equal to 0. We can use a zero product rule. So we can set this factor equal to 0, and we can set this factor equal to 0. Now, you might be thinking, okay, this one looks easy, but oh my God, what do I have to do with that? Do I have to factor that again, or do I have to use the quadratic formula? Well, good news. Whenever you do a difference or a sum of squares, this second part here is not factorable and not solvable without getting imaginary answers. So this is not going to give you any real answers. So on the homework tonight, yeah, if you look at the homework help, the answer key, well, they'll actually go ahead and solve it and get imaginary answers. I'm not going to require you to do that. So you're not going to bother, with that. You're not going to bother with that. Okay, you're just going to solve the real part. And this, you can see, is 2x minus 5 equals 0. You add 5, divide by 2, you're going to get x equals 5 over 2. And that's the only real solution. If you try to solve this, if you take this equal to 0 and you use the discriminant, remember the discriminant, it tells you if it's solvable or not. Well, b squared minus 4ac, this is your b squared minus 4 times a times c. What you're going to get is, this is 10 squared, which is 100, minus, this is 4 times 25 is another 100 times 4 is 400. Your discriminant is negative 300, okay? And if you get a negative discriminant, you do not have any real solutions. What you're going to have is two imaginary solutions. And there you go. X equals 5 over 2. All right, let's try another one. Is this a difference or sum of cubes? This is, well, let's see. Is it something cubed plus something cubed? And the answer is yes, it is. First of all, the one over here, 1 cubed is 1. So that's easy. 1 is its own cube root. For 27x cubed, what do you cube to get 27? 3 times 3 times 3. Right? 3 times 3 is 9, times 3 is 27. So that's going to be a 3 for that. And then for this is x. So there you go. That's your a, and that's your b. Okay, and there's your formula. And you can see it's a little bit different. This time there's a plus here instead of a minus, and there's a plus here instead of a minus, and here there's a minus instead of a plus. We have the a, we have the b figured out. So this is going to be a plus b, which is 3x plus 1, and this is going to be a squared, which is 3x times itself, which is 9x squared, minus a times b, which is 3x times 1, which is still 3x, plus b squared, which is 1 squared, which is 1. And that, okay, is that. So now we can just set that equal to 0, and now it's factored. So that's fully factored form. Okay, and I need to see all of this work either on the quiz or on the homework. So that's not fully factored form. So I do want to see you write this as a sum of cubes. That's going to be 1 point. The fully factored form is your second point, and then the solution will be your last point. Make sure you don't forget all that stuff. Okay, so how do we solve this? Well, like I told you a minute ago, the first factor is going to give you a real root, but the other two roots will be imaginary. So you can try to do this, but like I said, if you check the discriminant, it's going to be a negative discriminant. It's not going to work. So all you really have to solve is what's 3x plus 1 equal to 0? Well, you're going to subtract 1 and get 3x equals negative 1. Divide by 3, you're going to get x equals negative 1/3, and that's your only real solution. Now, like I said, in the textbook, if you look at the answer key, they're going to show you 2 more solutions that have i's in them, and I'm not going to worry about that. Now, this one's a little different because this one has more than one letter in it, but it's still a difference of cubes, sort of. Is 2 the cube of something? No. Is 128 the cube of something? Well, you may not know the answer to that, but if you take a calculator and take the cube root of 128, you will get a decimal. So no, it's not a perfect cube. So what's the problem here? This doesn't look like a cube minus a cube. In fact, that's a 4th power, 6th power. It doesn't look like the difference of cubes, but once again, remember that you have to take out your GCF. So your GCF here is 2, goes into both of these, and x. There's a 2 and there's an x in both of these, okay? And if you take out a 2x out of there, you get x cubed y to the 6th, and you take a 2x out of here, you get 64. And now, is this something cubed times something cubed? And the answer is yeah, it is. Here, I'll do it off on the side here. X cubed y to the 6th minus 64. What are you cubing to get this? And what are you cubing to get this? Well, for the 64, it's 4, because 4 times 4 times 4 is 64. For this, well, what would you cube to get x cubed? You get just an x. And what would you cube to get y to the 6th? Y squared. So there you go. There's your a, there's your b. So we have the 2x, which is the first factor that we got when we did the GCF. Don't forget that. Don't lose it. And now let me put the formula down here, and I'm just going to put things into place here. So the first term here is the a minus b. So it's this thing minus this thing. So it's xy squared minus 4. That's the a minus b. Now a squared would be this thing squared. So xy squared times itself. Well, the x's would be x squared, and the y squared would be y to the 4th. Okay, just multiply the red thing here by times itself. Plus a times b, so plus this times this. Well, that's just putting a 4 on here, right? So 4xy squared. And then finally plus b squared, which is 4 squared, which is 16. And that is fully factored. Now you might say to yourself, well, can I still factor this? And the answer is no. You don't mess with this last trinomial. It's never going to be factorable. Okay, and that's it for differences and sums of cubes. So that brings us to our last topic for today, which is how do you factor things that are in quadratic form? This is a second power right here. It's the highest power in this expression. So this is a quadratic expression. This is also quadratic. And for quadratics, we know how to factor quadratics. We've been doing it for a while now. So for instance, if there's no number in front of the x squared, meaning it's a 1, you just use reverse FOIL, right? So you just put down your parentheses, you put down your x's, find 2 factors of negative 15 that add together give me negative 2, 5 and 3, negative 5, positive 3, and that's it, reverse FOIL. Now, when there's a number in front of the x squared, a coefficient like that, you can't just say, all right, what are 2 numbers that multiply to give me 3? That doesn't work. So what you do is you multiply the 6, the a, times the c, and you get a times c equals 18, and you use that number instead of 3. So what are 2 factors of 18 that add to give me 11? Well, 18 would have to be 18 times 1, or 9 times 2, or 6 times 3, right? And it looks like 9 and 2, right? So this becomes 9x plus 2x, and we take it from there. So we know, and then we, factor by grouping from that point on. We know how to deal with quadratics. But what happens when the functions that we're given are not quadratic, meaning higher power than 2? Like this one here. This is a 4th power function. It looks a heck of a lot like this expression right over here. They're almost identical, except this is a power of 2, and this is a power of 4. So this is not a quadratic. So we can't just drop parentheses and put x's and x's like that and use reverse FOIL. It doesn't work. So what can we do to make this problem as easy to factor as this one? There's a trick here. So this is called using quadratic form, because this is technically not a quadratic, but it's formatted like one. It's in the form of a quadratic. It is not a quadratic, but it's in the form of one. As long as the following things are true. So follow me on this very closely. In a quadratic, the first power is a 2, the second power is a 1, and the third power is nothing. There's no x at all. So technically, that's considered x to the 0. So a power of 2, power of 1, power of 0. And the important thing is that the first power here is double the second power. And the last thing over here is no x at all, meaning x to the 0. As long as those things are true, you can do this trick that I'm about to show you on all the problems that we're going to do now. So here's the deal. Look at your expression. Can you write it in quadratic form? Well, here's the test. Is the highest power double the middle power here? Is this 4 double a 2? Yes, it is. It is double. And does this last number here have no x at all, meaning x to the 0? The answer to both of these questions is yes. This is double this, and this has no x at all. So that means it's eligible for you to use this method I'm about to show you. The method is called substitution. Now, it's not the same kind of substitution that we did back in substitution and elimination, but it's still considered substitution. We're going to substitute something for these x's to make this a quadratic equation. Or sorry, it's not an equation, expression. So how do we do this? Well, we do this by recognizing that this x to the 4th, it's really just x squared with another square on it, isn't it? X squared squared is x to the 4th, okay? And if you realize that, say, all right, so, and then this right here, this is minus 2x, but then that's also squared. And then we have 15x to the 0, which even if you double or square a 0, it's still 0. So you realize that there's a relationship here. We just have to divide this by 2 and divide this by 2, and dividing a 0 by 2 doesn't change anything. So here's what we do. We say, all right, I'm going to pick a different letter, not x, a different letter. And the letter we're going to use is u, the letter u, okay? Because that's what's in all the textbooks, so we'll use it. And we're going to take, it's called a u substitution. We're going to do a u substitution by deciding what power would bring this 4 down to a 2, which is what we want. And the answer is 2. What would you divide 4 by to get x squared? You're going to make 2. So here's what we're going to do. You're going to make this 2. You're going to say let, this is called the substitution statement, let u equal x to the, and you choose the power. In this case, we're going to choose a power that when we divide the 4 by it will get us our quadratic. Well, x to the 2nd. And like I was saying before, this is really just x squared squared, right? Minus 2. And this is right, oops, this is x squared as well. And this is minus 15. So you can see these right here, these x squareds, they're going to be the x squared that we're using here. That means wherever you see an x squared, you're just going to replace it with the letter u. So this now becomes u squared minus 2u minus 15. And you see that this is now written in, the first question was write in quadratic form. This is now in quadratic form. So in the homework tonight, they're going to ask you, if possible, write the thing in quadratic form. That's what I've just done here, okay? You have to pick the right power of x to be your u, and then substitute in the u's in the right spots. And there you go. Now that it's a quadratic, you can factor this using reverse FOIL. This is a u, this is a u, and we already know that this is going to be minus 5 and plus 3. Now, here's the thing though, and this is the tricky part. You can't box this as your final factored answer, because what the heck is u? You made up u, okay? You made that up. You can't leave it there. So we need to put back before we're, once we've factored which is what the u is for to help us factor, we need to put back the u the way it was. And u equals x squared. So now we need to put back the x squareds. Wherever you see a u, we're going to return an x squared now. So this becomes x squared minus 5, and this becomes x squared plus 3. Now, neither of these is factorable anymore, so we're just going to box our answer, and this is fully factored. Okay, and that's fully factored form there. So here, there are 2 steps here, and you need to show all these steps in your work. You need to write this in quadratic form first, and then do your factoring, and then what's called back substitute. The x is back, the x squared is back where they were. All right, let's try another one. This time we have an 8th power function. Now, we don't know how to factor 8th power functions, but could we make this into a 2nd power function? The answer is yes. If you divide this 8 by what power? Divide it by 4. It becomes an x squared, right? So we want to divide this by 4. And how do we do that? We say let u be x to the 4th, okay? You pick the power that will make this a 2 when you divide. So now what you realize, hopefully, is that this is really just x to the 4th squared, okay, minus, and this is another x to the 4th, right? Just copying that down, minus 20. So the 2 red things are this, which means I can substitute a u for them, and this becomes u squared, okay, minus u minus 20. Now this is a quadratic. This is in quadratic form now, all right? And that's the part of the homework where they say write in quadratic form. So I'll box that as a partial answer. But now we have to actually factor. So let's go ahead. This is also reverse FOIL because there's no number in front of the u. So just put down your u's. 2 factors of negative 20 that add to give me negative 1, right? Well, 2 numbers that multiply in 5 and 4. And since this is negative, this must be the bigger number is negative, and this is positive. And there you go. That's factored. The factoring is done, but we cannot leave the u's here, so I'm going to put back the x squareds, sorry, x to the 4ths this time. So we get x to the 4th minus 5 and x to the 4th plus 4. Now, neither of these is factorable, so we're fully factored now. So the trick is simple. Decide what, well, first of all, you have to make sure that the highest power is double the middle power and that the last term has no x at all, okay? So if those things aren't true, you cannot do this. So make sure that those are true before you even start anything. All right, let's do one more. Okay, let's try this next one here. So this next one's a 6th power function. Now we definitely don't know how to factor 6th power functions, but to bring it down to a 2nd power, which is a quadratic, which we know how to factor, we'd have to divide the 6 by what? Yeah, divide it by 3. So here's how we do that. We say let, you have to write this by the way, let u equal x to the what power again? 3. Because 3 is going to, dividing this by 3 and dividing this by 3, this will make this a 2, which is what we want. It'll make this a 1, which is what we want. And of course, this was 0 to begin with, so dividing it by 3 is still a 0, so it doesn't matter. Okay, so how do we do this now? Well, now that we know that let u equals x cubed, we realize that this is really 2x cubed squared, right? That's going to be x to the 6th, plus 7x cubed plus 3. So really that's just the u and that's just the u. So we get 2u squared plus 7u plus 3. And that is now written in quadratic form. And that's the part, so some of the homework questions will just be to do that, and some of them will be to write in quadratic form and then factor. Okay, so now we've gotten that far. How do we factor? Well, can we use reverse FOIL here? No, we can't use reverse FOIL because there's a 2 here, so we're going to have to use the AC method. So 2 times 3 is going to be 6, so AC is 6. I need 2 factors of 6 that add to give me 7. That's pretty easy, 6 and 1, right? So we're going to split this into 6u plus 1u, and the rest of this stays as it is. And if you remember from the AC method, you just take the GCF of the first 2 terms and the GCF of the last 2 terms, right? So let's see, 2u is the GCF here. And we have, let's see, it's going to be u plus 3, right? If you distribute that, you get these, so that works. And you remember the AC method, the other set of parentheses has to have the same thing. So I'll just start with that and say, all right, what do I multiply by u plus 3 to get 1u plus 3? Well, it's the same thing. So just 1. There you go. All right, and now that we have that, all done here, we say 2u plus 1 is one factor, and this u plus 3 here is the other factor. And here we are, we're done factoring, but we're not finished because we have to put back the x cubed here. So don't box that. You need to go 2x cubed plus 1 and x cubed plus 1, putting back all the u's, making them x cubes again. Now, neither of these is factorable, so I can stop here, and this is fully factored form. All right, now this last one here, we want to write in quadratic form and then factor. Well, we'll do our check. Is 6, this power, double this power? And the answer is no, 6 is not double 4. So that means you cannot write this in quadratic form. It's not possible. You'll notice on the homework they say, if possible, write in quadratic form. Well, here's an example of where it's not possible. If this isn't double this, then this doesn't work. This would have to be a 3, okay? Then you'd be double. So can't do this problem, and it's not factorable. Okay, we're done. See you at the next video.
Check this.